Welcome everyone. This is Professor Richard Holowczak, and this is the Database System Development Lifecycle Lecture. Just as a brief review, database systems consist of databases, database management system, and applications. The database, as you may recall, is a shared collection of logically related data. Descriptions of that data, we sometimes call metadata, designed to meet the needs of an organization. We can simply think of the database as the data. The database management system is software that manages that data. You may have heard of software like MySQL or PostgreSQL or Oracle, Microsoft SQL Server, Microsoft Access. There are dozens of them. The database management system software is responsible for storing and updating data, running queries, processing transactions. It's responsible for backing up and recovering the data in event of a failure. And the DBMS is responsible for security. The third part of the database system is the application. The application we can break into two parts. The user interface, which is what the user types things into and clicks on and swipes on their phone, and the business logic. The business logic is the software code that implements the rules of the business. Most students are familiar with a database system like this one. This one happens to be called CUNY First. And you can clearly see the application has a user interface. So here are some combo boxes, some text boxes that we can type things into, some buttons that we can click on, some menus that we can navigate. This is all just to interact with the user. When the user clicks submit or save, some business logic comes into play. And this business logic is a piece of code that might alter the data in some way. It might check that the data is complete. Finally, that data or that query ends up being sent to the database management system. The database management system uses all of its software functions to do what it needs to do to query or manipulate data in the database. So we have these four layers together: user interface, applications, business logic, the database management system, and the database. So a question comes up: how does one create or develop a database system? And you might think it's as simple as someone asking, hey, we need a system to manage our inventory. And a software developer says, sure, let me get started coding right away. How many of you think that this is the way things work? You have business people just walking around all day saying, I wish we had a system to do X, whatever X is. And programmers immediately jump on their laptop and start coding. Well, as you probably guessed, that's really not the case. In reality, when there's a need in an organization for a new system or an improvement to a system, a bunch of questions immediately come up, like what resources do we have? Who's going to be working on the project team? What is the timeline? When do you need this done? What will the new system actually do? What data does it need to store? Who are the end users and what functions do they need? These are just a few of the questions that come up at the very beginning. In order to answer questions like these and more, and to try to keep the project organized, professionals have developed the system development lifecycle. The systems development lifecycle has been around for many, many years and in many, many forms. The list of bullet points I'm showing you here is just one way to sort of break up the lifecycle. Why do we call it a lifecycle? Because it has a beginning, middle, and end. It has a series of steps almost like a recipe. At the very start of our system development lifecycle, we need to identify the problem, opportunity, and objective. What is the problem that the business or organization has? What is the opportunity that they might want to take advantage of by having a new system? And what is the objective? What will the business or organization be able to do once this new system is in place? After that point, there needs to be some thought put into how is this project going to be planned? Who's going to work on the project? How many hours a week? What does the team look like? What type of resources do we need? Do we need just technical people? Do we need a mix of technical people and business people? And what are the timelines? How soon does this project need to be done? And what are the milestones along the way as this system is going to be developed? Once the project plan is in place, then we can start gathering requirements. And typically, these requirements come in two general categories. Information requirements, which you can think of as data. What data does the system need to store and have available? And processing requirements. How is that data going to be processed? So these requirements need to be written down, they need to be documented so that we can move forward in the process. The next step is what we call system design and modeling. In this step, we read the requirements and we provide models. You can think of these almost like mock-ups or little samples of what the system might look like. And specifically, we'll look at models for data and we'll look at models for how that data will be processed. With the design and the models in place, now is the time the developers go into work. Now they can take those designs and the models and they can actually develop things like databases, and they can develop things like applications, including the user interface and the business logic. This also incorporates testing. We need to make sure that those functions are working properly, that data is being stored and processed in the right way. Along with the system development, we would also need to develop documentation about what the system does so that when it comes time to train end users, they have something that they can work from. Typically, the way a system works on a technical level is probably not the best way to teach end users how to use that system. Finally, the new system is deployed and we evaluate its effectiveness. That means it goes into production, actual users start using the system, and they provide us feedback, what they like, what they don't like. And that leads us into maintenance. If there are bugs or things that are missing, they need to be fixed. Those features need to be added. As the system grows over time, new features might be added, and we collect all of that under maintenance. If you are enrolled in a systems analysis and design course, you will spend your entire semester going in depth into every single one of these topics. You will also learn that there are many variations of the system development lifecycle. Some of these variations include the waterfall methodology, agile or lean methodologies, scrum methodologies, and so on. These variations and these methodologies are a little bit too detailed for what we need to do in our database course. So, what I'm presenting here is a simplified version of the system development lifecycle. I call it the database development lifecycle, and it predominantly focuses on the data needs of the organization. We still do end up building an application, but most of the focus is on the data because this is a database course. So we're going to begin in a similar fashion. We're going to identify organizational problems or opportunities. We're going to gather requirements from the users, focusing mostly on the data needs. What data needs to be stored and how does that data need to be processed? We will then create what's called a conceptual data model. And this is a particular kind of data model that we will be able to use as a communication device between the technical people and the business people. We will convert that conceptual model to a logical data model, which we will then optimize. And then finally, we will implement that physical model in a database management system, and then we will create the application. I mentioned three types of models, what we called conceptual, logical, and physical. And so I wanted to provide an analogy so that you can see a little bit about what direction we're headed in. So my story is, when I first came to Baruch College, the vertical campus did not exist. However, you could go into the library building across the street, and they had this glass case sitting on a shelf. And inside the glass case, this is about the size of a fish tank, I think, there was a cardboard model of the vertical campus. In other words, it was a model of what the building would look like once it was completed. The nice thing about this model is that anyone without any particular architecture training or construction training, without any particular set of skills, anyone could walk in and take a look at this model and could understand what the building would look like when it was done. You could sort of count the number of floors and how many offices it would have, how many classrooms, and so on. So I treat this like a conceptual model. It's the concept, it's the idea of what this will look like once it's done. Again, this is like a communication device. It's a way of showing non-technical users what something will look like when it's done. So we call that the conceptual model. Now, can a construction worker come in, take a look at this model sitting inside of this fish tank, and immediately pick up their hammer and start building the building? Probably not. We need something a little more technical. We need something a little more specific. And so this conceptual model is converted into a kind of logical model. And here, in my analogy, we're looking at a set of blueprints. The blueprints are very, very specific drawings that give the height and the width and the weight and the materials and where the cables will run and the wires will go and where the doors will be. Very, very detailed, very specific, very precise set of plans. Okay, and I'm going to call that sort of my logical model. Once we have converted from our conceptual model to our logical model, then our technical people, in this case they're construction workers, can get to work building the physical thing. So again, the construction workers can't look at your conceptual model and say, oh yeah, I'll build you a building like that. They need something in the middle. We need some technical drawings that maybe the casual person, the non-technical person, would not understand. But it certainly means something to the technical people, in this case construction workers, that actually have to do the work of building this. So that's my analogy, the conceptual model to logical model, which then eventually becomes a physical model. We're going to start by identifying that organization problem or opportunity. We will gather our requirements by interviewing our users. And again, we're mainly going to focus on the data. And then we're going to create what's called a conceptual data model. This conceptual data model has a name. It's called the entity relationship model. And that will be the topic of the next several lectures. Once we have created this entity relationship model, we will then convert it to a logical data model, which we call the relational model. We will optimize that logical data model through a process called normalization, and then we're going to implement that model in a database management system, specifically Microsoft Access, and we'll use some structured query language. And then we'll implement the application. So at the start, we will begin by identifying our problem or opportunity, we'll gather requirements, and we will create this first conceptual model we call the entity relationship model. That's all the notes I have for this lecture. As always, I have additional notes on databases and data warehousing. You can find it on my website, holowczak.com/dbnotes. Thanks, and see you next time.